welcome everybody to today's Expert Talk Online. I think it's a top of mind as leaders are reflecting. I know over here in the States, we're talking a lot around Uber, Slack, and the hack, and that all leads to security. Just this week at Dreamforce, former Salesforce CEO Mark Benioff addressed the recent hack, saying there's no finish line when it comes to security and social engineering and people. So today we're going to talk about embedding security in the delivery cycle with ease, breaking down some of the misconceptions when working in the dev security ops space. I'm Lisa Copeland. I'm North America product lead here at EcoExperts, working with a US company in the audio streaming satellite ad tech space, building platform for growth to power some business model innovation. Security is definitely top of mind and how to do that. And it's my pleasure to introduce our speaker today. Chris Rutter is security principal at EcoExperts and specializes in transforming security technology and processes to support delivery at scale and measurable security improvements. Chris has helped transform how security is approached within small teams and on large digital platforms and everything in between. Worked on various business verticals, including government, retail, financial services, all the places where security is top of mind. In this talk, Chris draws on his vast experience with high profile and high security focused organizations and to dispel some of the myths and address the frustrations. When you say you have to go talk to people in security, we know it well. We want this to be as interactive. And we're leaving time for audience questions at the end of the conversation. So please do start adding your questions now using the Zoom Q&A function. And without further ado, please welcome me in welcoming Chris Rutter.
Thanks a lot, Lisa. That's brilliant. I'll just share my slides and then we'll get on with the talk. Let's see. Okay. Can we see the slides?
We can.
Okay, fantastic. Let me get on full screen. Okay, so the talk we're going to go through today is called DevSec-Oops. Security doesn't have to be so hard. And this is based on my experiences. Like Lisa said, thanks for the great introduction, working across lots of different sectors for different size teams, trying to help them make security easier and build more secure systems. So I think we can skim past the about me. You did such a great job in introducing me, Lisa. Thank you. So if we dive straight into the problem domain, so we're trying to solve problems here. That's a lot of my job in security has been based around that over the last sort of 5 or 6 years. So I guarantee that the people on the call will have experienced some of these issues in the past and are probably experiencing some of these issues today. So we've got security slowing down delivery. We've got big bang risk assessments. We've got per project penetration tests. We've got kind of email-based workflow, which we could call kind of email tennis sometimes, or email ping pong. And it really clashes with how we deliver software now in most organizations, rapid, iterative product delivery. We tend to see large amounts of duplicated effort across teams. So whether they're going through the same security review processes, or they're being asked to fix the same pen test finding results, there's a lot of inefficiency there, and teams kind of wasting time doing the same things. There's large chunks of security work that sometimes come from nowhere. This could be right at the end of a project that you thought was great and secure, and suddenly you've had a review and you've got 4 weeks worth of retrofitting of security controls to put in there. And also sometimes, with things like Log4Shell, like a big critical vulnerability, we have to drop everything. Very disruptive chunk of work that helps us secure our systems. And then also with all these activities, we often find there's difficulty demonstrating the value of the work. Often we find ourselves just trying to pass a single security gate being the main objective. And there isn't really any measurement of value or progress. It's kind of binary. It's like, did you pass or did you not pass? And there's definitely techniques that we can use to improve all of these problem statements. And we're going to look at some of the practical ways that we've been doing this over the last few years. So if we dive straight into, I think it's very simplified, but this is kind of a typical software delivery lifecycle. The delivery team is, we conceive a product, we then do a little bit of design, sometimes more upfront than others, And then we build through a lot of different build cycles. And then often in the scenario that we're looking at, we then go for security review. We're not really providing any kind of assurance or any security inputs to that security review from our architectural design from when we built our software. We then have an InfoSec or a third party doing a risk assessment or a pen test, and all of the kind of security assurance that we need to release this securely and prove it's secure all happens, it's fully the responsibility of a separate team. Now those lines there in between the two teams, this organizational gap, that's when we get the email tennis, that's when we get kind of delays and friction, and we often find kind of less secure systems, and we find projects that are delayed and nobody's really happy about the situation. So to kind of understand how we can fix these things, I mean, first of all, if we look at trying to understand what the root cause of the problem is. Now, if you look at again, it's a simplified version of an organizational diagram. So if we've got the InfoSec team up there at the top, they have lots of different roles other than securing our systems. But the main one that affects us when we're delivering software is kind of the AppSec specialist. Now, this could be a team, it could be an individual, but it's their role usually to help us secure our software before it gets into production, and sometimes after that when it's being operated. Now, their primary role is to provide security assurance, is to prove that we're doing the right things to secure our systems, prove that we've got evidence that we did the right checks, we've got the right balances. Then we've got usually way more teams of engineers and delivery leads, product delivery teams, who are really focused on rapid product delivery. We want to deliver rapidly, we want to deliver safely, we want to deliver stuff that's useful to our customers. Now, the ratio between these two departments, I mean, I've seen ratios in terms of AppSec specialists to engineers. I mean, if you've got 1 to 20, you're doing well. I've seen 1 to 50, I've seen 1 to 100 kind of AppSec specialists trying to service up to 100 engineers, trying to secure their systems. And the engineers want to release as often as they can, as fast as they can. And you can obviously see now where some of this tension is going to come from, and why these workflows, it's going to be very difficult to make them optimal. Now, when we say security assurance, so what do we mean by security assurance? So this table here is taken from OWASP SAM, that's the Software Assurance Security Model. And this is kind of an assessment tool for InfoSec teams to check how well they're doing at providing software assurance. A lot of teams can assess themselves and they'll base how they actually build their application security program on these types of criteria. So basically we're looking at things like, do you classify applications according to business risk? Do you scan your applications with testing tools? Do you test for security controls? Do you manually review high risk components? Do you patch vulnerabilities? Now, I'm sure these things are probably familiar to everyone on the call. The thing is, at the moment, a lot of these things tend to happen at that big bang kind of risk assessment, security review phase. And these things are really important. I mean, if your company was breached or they're trying to pass a regulatory audit, being able to prove that these things are happening is incredibly important. If you can't prove these things are happening after you're breached, your fines are going to be sky high. If you can't prove this to an auditor, then there could be chances that you fail your audit or you have a big program of remedial work to carry out. So assurance is incredibly important. I think the place where you can add value is, where do we create the assurance? How do we provide the assurance? So the ethos basically, I think, should be, you build it, you secure it, and then you demonstrate you've secured it. We don't wait until the very end and ask a security team, is this secure yet? I know that's not the way we want to work, but that's the way it is in a lot of cases. So we can proactively secure our code, given some guidance, and we can proactively provide evidence that we've secured it. And then that makes kind of the security team job a lot easier, and it allows them to allow us to work a lot easier as well. So, okay, if we buy into this philosophy, this is what we're going to try and go ahead and achieve. Now, this all sounds great, but practically, I've seen people try this approach, and there are definitely a few gotchas that I've encountered over the last few years. A lot of the techniques we're going to discuss aren't brand new. You will probably have heard of a lot of them before, but I'll kind of share information on how we can make them work, how we can make them valuable. So some of the gotchas are basically, don't try to solve all of the problems from day one. It does take time to change processes and build trust, way more time than it does to build new systems. So start with a small slice of things you can easily change and go from there. Don't try and design a brand new workflow. Don't try and change lots of other teams. Choose one team or choose one set of one system, one project, and start from there. You really focus on the value of what you're doing. A lot of the techniques we're going to look at, if done without value in mind, can waste a lot of time and be very expensive in terms of money and in terms of effort that's involved. So make sure you really don't start any initiative without a clear value plan, and make sure you can measure if it's actually giving you value or not. We don't just do security things because it's on a checklist. We do it because we can prove the value of what we're doing. And also, perfect is the enemy of good. As long as you can prove why you made the decisions, and that's kind of documented somewhere, it's okay if it's not perfect, as long as it's much better than it was before. Now, often in security, we get hung up on that. We say, oh, what if I don't have this part of the flow? What if this happened? What if this control was subverted? We have to think that way, but it doesn't mean we have to go from suboptimal to perfect. We can't iteratively improve as we go. So with all that kind of stuff in mind, if we dig into some more concrete examples, so where do we start? If we want to start improving the scenarios that we outlined earlier on. So the first thing I usually find that's really useful is what we need to do is categorize. So what are we going to improve first? How are we going to make our lives easier as product delivery engineers? And how are we going to provide the right security assurance to the security teams? And we're not going to fix the whole world in the first instance. What we're going to do is categorize what we call a low risk software change. So in most cases, this could be what we call a feature. So it could be an existing architecture. We're just changing part of that architecture to build a new product set or add new functionality for our customers. And we carry out an exercise with InfoSec ahead of time. Now we can fast this together quite quickly. And we basically look at, okay, what are the checkboxes that I can categorize this release as just a feature that's low risk? So in terms of the architecture, is it existing architecture, or is it using an approved pattern, or is it brand new? What kind of data is it processing? Are we having like really sensitive data? Is this going to move money around and be subject to payments? Are we using existing security controls like auth and data protection, or are we writing new ones? Are we using an existing tech stack, or are we going to use brand new technology? And once we can categorize all of that and we have a framework in place, which can be very simple like this. I've used frameworks not much more complicated than this before. Then we can start having conversations about, okay, let's work together to now change how we secure these types of features, given the fact that it's classed as kind of more low risk, given the fact that we probably do these things more often than any other change. There's a huge chunk of value to be gained there. And it's usually a lot more palatable for an InfoSec team than us just going and saying, we don't like your workflows, we want to change them all. We say, okay, we'll change a small part of it for one type of change that we have. Here's the framework, here's the documentation, here's the evidence why we made that decision. So once we've done that, that frees us up. We look back at this diagram. Okay, now that we've categorized these kind of small feature releases, most of these things are just going to be code changes. We've already said that we're not changing architectures. So what we do now is we say, right, rather than all of the security assurance happening at the end, let's work together so we can provide that assurance as we go from our build pipelines, provide it to you in a way that you can use as evidence if you're audited or if we were ever breached. And then we can shorten that, that final security assurance piece to either basically just verification of the evidence that's been provided, potentially even a very tiny short risk assessment, depending on the change. The value statement that we're looking for here is we want to reduce the lead time for our changes for simple features that we develop. So the first approach usually, and what I would recommend, is to look at code scanning tools. And I'm sure most of you have had experience with security scanning tools. They won't be new to you, but there are a lot of gotchas. So generally what tends to happen is they're seen as something that's owned by the InfoSec team. The InfoSec team procure a tool. They get a tool which they think is hopefully going to scan everything they need to. And what they love about the kind of big tool that they usually buy is that it has a centralized server. They can log on to a UI and give themselves assurance reports. So they can tick off those boxes we saw earlier on to say, do you track your defects? Can you prove that your teams are scanning the systems for security vulnerabilities? And can you click a button and create a document to prove that to me if I'm an auditor who's tapping you on the shoulder? So that's why we usually get these kind of bigger, more heavyweight tools. Thing is, though, in a modern architecture, we have lots and lots of different moving parts that make up a product. It's not just one Java backend service anymore that does everything. We have lots of microservices, we have databases, we have different third-party frameworks. We might have serverless, we might have API gateways. A lot of the time, we might have a mobile app or front-end JavaScript components. A lot of the time, these big scanning tools, we buy one of them because it's kind of expensive and it gives us this dashboard. Won't scan a lot of the things that we care about. And a lot of the time, the licensing models for these tools are kind of per application. So you end up paying a lot of money for each application, and it's only scanning part of your architecture. Generally, because InfoSec are rolling it out and they don't have a lot of security engineers, it's very long rollout. You know, this can be 6 months, 12 months to roll out to everybody. And the procurement can take a long time too. And obviously, like we said, it's not going to cover a lot of the new tech. So I found that this can be one way to detract from the value of scanning when we just get one big scanner in and we really aren't able to scan everything that we need to. So the approach that we've taken in the last few years, and an approach I've seen that works very well, is what we call kind of bring your own scanner. So now what we're going to do is we're not just going to rely on one big scanner. We might still use large vendor tools if they have very good scanning engines. What we're going to do is choose the right tool for the right job. So we might have a specific scanner for front-end code. We're going to have hopefully cloud-native scanners like AWS GuardDuty or Google SCC that are going to scan cloud resources for us, like databases and cloud ingress and serverless functions. And then we'll choose a scanner for our backend code, which might be a kind of a bigger kind of scanning vendor, or again, it might be a lightweight scanner. The key part, though, is we want lightweight and specialized or cloud-native tools. We want an engineer to be able to build and own this. We want an engineer to be able to, within a few days, get it running, get it working in the pipelines, feel comfortable to use this tool. We absolutely don't want a 12-month procurement cycle, because what happens when our technology choices change in 3 months' time and we want to use something else that this tool doesn't scan? At best, we lose coverage. At worst, we're told we can't use that tool, we can't use that language or that technology because we don't have the scanner for it. And nobody wants to be in that situation. But the key thing here, we choose the right tech for the right job. Engineers are the ones building these things. They're the ones putting them in pipelines. They're the ones testing them. And they're the ones who make those decisions. Now we're thinking, though, we do still have that requirement to provide assurance. You know, if we can't give evidence that we're scanning and that we're dealing with vulnerabilities, then we can't, use this to ease our workflows. This is a typical output for one of these lightweight scanners. Engineers love it because they get rapid feedback. They find out straight away that they've got a security vulnerability and fix it there and then. Excuse me. But it's not we can't ask a security professional when we want to release our new feature after 2 months' work. We can't just say, oh, can you just go and look at all the pipelines? And I promise you the data is there. That isn't really going to cut it. So an approach that I found works really well is we use our different pipelines here. So one of them scanning Terraform, one of them scanning Java code, maybe scanning React. We have our lightweight scanners, and we build a very lightweight scan forwarder, basically, which can be included in these pipelines as a job template, as a Python script. This is managed by engineers. They include it in the pipelines, and all this thing does takes the output from the scan, which could be a JSON file, parses that output, forwards it into a database we create. Again, very easy to create this in the cloud. We forward all of our scan results to this database, and now it's a bit more rough. We don't have a UI for it, but now we have the ability to track all of our vulnerabilities, all of our scans. We have highly contextual information about which pipeline ran the scan. We can configure the forwarder to allow us to say, this is the team that sent the scan, and this is how you contact them if you need to. All that information is now in our database, and all this is very easy to set up. Can all be done by engineers very quickly. Now, if we want to provide assurance and use this to get ourselves a more streamlined workflow, we can do it at the beginning, a very kind of roughshod way. We could even just take an export using SQL as a CSV file and email it to the security team when we want to release. It's a bit more manual, and it's a bit of a pain, but it works. We could create a Google form or like a web form to upload those files, and we can add more information, have a few more questions. Or we could, if we want to scale this out to a much larger organization, we could build something like a Grafana dashboard on top of that database. And then we get some really cool features like, we've got a UI now, we can export at a button, we can apply vulnerability policies, we can look at trends. And setting up a Grafana dashboard, again, it's relatively simple to do. It's definitely not a 12-month procurement period, and it can be done. It's technology that's familiar with engineers. Okay, so this is brilliant. We've got the ability to scan all of our code. We've got the ability to now provide evidence and assurance that we scanned our code. You're probably asking yourself, okay, but who does all of this stuff? We don't have many security engineers. We've already talked about that. So now we look at the idea of security champions, or potentially like enablement teams if you're in a digital platform. Now, I'm sure, again, you will have heard about security champions before. This won't be a new concept, but almost everywhere I've been, I've seen these initiatives fail because they're launched with a lot of fanfare and everybody's really excited about it. And they lack the cohesion of a virtual team. They don't really have a mandate to build or work or a responsibility to actually drive improvements. A lot of the time we end up with a very enthusiastic group of engineers who do extra training every now and again, which is a good objective. But what we don't have is this cross-cutting security engineering capability and this kind of bridge with the InfoSec team, which is what we need if we ever want to take ownership of this stuff and kind of build our own security capabilities. So in a kind of functional security champion virtual team, I would say it's very important to have a kind of delivery lead, somebody who understands backlog and delivering value. You obviously need a security subject matter expert who's going to act as kind of a business analyst or a product owner. And then you have engineers who are committing to be champions. Now you can kind of rotate people in. You can say, right, 1 week in 8, this engineer is going to be part of the security, the security champion team. Now it gives you a capability to start building things that can be shared. It really helps to enact a team charter for this. So it's not just who wants to be a security champion. That's great. I get some extra training. There's a set of responsibilities there. There's a concrete requirement that you're the person who manages the scan results. There's a commitment to providing, 1 week in every 8 or, every Friday or whatever into dev commitments. And ideally on that person's kind of appraisal or how they're reviewed, we add that to their role and say, you should be demonstrating the value you've added as this security champion. The things they get is they'll get faster product releases because they've got these new streamlined workflows. They will get specialist training and they'll be able to have a system-wide impact. They'll get experience of writing code across lots of different teams. That's very valuable, especially for kind of mid-level engineers. Okay, so now we've got a more streamlined process. We've got the ability to give assurance to the InfoSec teams. They will accept that and they'll allow us to now release features with basically just sending them an email with the scan results and why we assess that as a feature. And that becomes a much quicker exercise. And now we can release software much faster with much less friction. The kind of tangible gains that we have is when we're no longer kind of slowing down feature delivery. Our time to market can be much faster. We can deploy to production much earlier and more often. We were probably bunching up releases beforehand because we were scared of going through kind of pen tests or risk assessments. Now we can deploy to production a lot more quickly, given that it's classified as a feature. There's a lot less duplicated effort across the teams because we don't have all these duplicated pen tests for these small chunks of code. We don't have the big old risk assessments either. And by having a security champions team, we've got a virtual team whose whole purpose is to build improvements for everybody else. So we're scaling out that security engineering capability too. Tangible metrics, so we can measure the effectiveness of this. So we can measure, what's the release frequency of what we consider as low risk releases, and that will go up, 30%, 50%, it depends on your appetite for fast releases. And now that we've got a vulnerability database, we can also say, yeah, we fixed 95% of our critical vulnerabilities within 5 days. And we're trending downwards on medium vulnerabilities too. These are things that the champions can help improve. We've got measurements for these things. There's been a clear value statement and we've realized value from these changes. Okay, so that's brilliant. We've now given ourselves a much easier path to production for features. So what's next? So next, we're going to look at securing the architecture. So we've started off at an easy to control area, which is our own build pipelines. We've categorized low risk changes. So we've got buy-in from InfoSec. Now we're going to go, okay, we do have to actually build large architectures sometimes. We do have to make changes to big complex parts of our system. So let's use the same techniques. Let's bring in the assurance that we can provide into that architectural design phase. And we'll do it by using a technique called kind of secure design. Again, the objective we're trying to get here is that the verification step by the InfoSec team, much shorter, much easier, because we're proactively giving them a lot of the assurance that they require. The actual value statement is we want to reduce expensive retrofitting of security controls later on in a project, and we want to reduce lead time for these kind of larger system changes. So the way we do that, again, we go back to our risk classification. We can effectively classify what the difference is between kind of a medium risk architectural change and a much higher system risk. You know, a medium risk would be that we're building a new architectural pattern, but it's in an existing cloud environment. We're maybe using PII data in a new use case. We might be changing kind of data protection controls, or we might be using a brand new tool. We might be putting Elasticsearch in for a critical reason. And then we can say, all right, for that kind of change, we will still have a risk assessment, but it'll be much more stripped down. It'll be targeted because we're going to use approved patterns, and we're going to kind of front load the secure design. So the way we do that is there's quite a bit of information here, but if we start on the left, the first thing we do is we just categorize like what are the different sort of things that are going to be security sensitive in terms of what our application does. So is our application going to store PII data? Is our application going to access secrets? Is our application going to be able to make payments or move money? Now we can just work with InfoSec to figure these things out from the top of our heads. I think we'll have a good idea. We can also look at past risk assessments. You know, we just look at all the past risk assessments and we look at all the common threads, all the things that security kind of asked us to fit extra controls around, and we have a ready-made list of these things. So we start off with the ones that have caused us the most trouble in the past, the most retrofitted work. Let's start with PII data storage. It's always a red flag for a security team. So the next step, and this is really critical, so we sit down and again, we look at the previous risk assessments, we work with the InfoSec professional, and we say, all right, can you just give us a set of clear requirements, what you're looking for when you review one of these, a system that's storing PII data? Can we get clear crystal requirements that we can think about right at the beginning of our project and plan into our project? So we know we have to think about those things, and we know we have to design them, and we know we have to work with you as we do so. So we might get it with a list of things like least privilege access or, you know, data protection. We drill into this. Obviously, this would be more complicated in real life. We might have to have a defined admin role. We might want conditional access for production. All these things where if you find out at the end are going to be very expensive to put in. We know early now, you know, we're building this ever-growing library of security requirements. Now, we may have seen libraries like this, but if they're managed by kind of a corporate security policy and they're very high level and they're very far away from engineers on the ground, I'm sure if you've looked at one of these kind of data protection policies, it's not very useful when you're sitting there trying to design a new system. And it didn't really give you much of a clue, much help right at the end of your project when you were asked to add a lot of extra controls. So the key part of this is engineers own this. We're driving this. It's language that we understand, but we're using the security team as subject matter experts here. We build this, we own it. They're the experts who tell us what to put in it. Then we can move along further to the right. Then we can look at, okay, we don't just have the requirements now. We're going to save you even more time. We're going to make it even easier to get your risk assessment approved. We're going to have agreed patterns. So we're going to have granular technical detail of exactly what conditional access looks like, who must approve it, how long the access should last for. We know exactly what an admin role should look like and who should be able to have it. You know, if it was encryption, we'd be talking about particular algorithms and particular encryption patterns that you should be using to meet these requirements. So now if we start having a set of these agreed patterns, you go for your, you know exactly what you need to implement right at the beginning of your project. Right at the end, when you go for security review, the conversation goes something like, Okay, so you're doing encryption. Did you use an approved pattern? Yes, I did. I used this pattern. That approval process is a lot shorter and a lot easier. And then right at the end there, technical resources. Now you may have the capability to build cross-cutting security tools. You could build a secrets management mechanism that people just get for free. You could build a tool that allows them to manage conditional access to a database for 2 hours and allow people to use that for free. You could build a set of IAM rules that reflect what an admin should be able to do and share those with people so they can use for free. Now, in my experience, it's best to have a mixture of these things. Some of these things work best as cross-cutting controls that you build. Some of them work best as patterns. Some of them work best as just requirements. If engineers are owning these things and gradually kind of iterating on them, I guarantee that you'll find the best kind of combination for your environment. I wouldn't want to just sit here and say, you have to build cross-cutting security controls, because for some environments that doesn't work. If you're on a digital platform, maybe it works great. If you've got 5 Scrum teams, maybe not so much. So once we've done all of this, we've now got a secure design library. We've built up from left to right. We know how to categorize our system. We know we've got a set of security requirements. We might have some patterns and we might have some technical resources. As we've said, that risk assessment becomes a lot more different now. We know exactly what we need to design in at the beginning of our projects, and the risk assessment is relying on pre-approved patterns. So it's much, much shorter and there's much less surprises. What do we gain, if we successfully implement this for our architectural changes? So we should get faster delivery of our larger system changes. We've got this solid set of security requirements, so we should be able to build them in from the beginning and reduce the length of the risk assessment. We should have less duplicated effort because we've got the patterns, we've got some of the shared tooling. We don't have the same teams doing the same reviews, getting the same requirements, building the same controls that are different every time. We're starting to share the knowledge and share the wealth here. And we're definitely going to get a reduction in big ticket kind of retrofitting. A lot less of the time we're going to get right to the end of a project and be suddenly asked to throw in all of these security controls. So the tangible metrics on these things, so the number of planned security stories that you've factored into your projects should go up. So let's say, it goes up 40%. The number of unplanned security stories that happens after your kind of security review should go down drastically, should go down by a huge amount. And you can kind of extrapolate the lead time from this as well. Okay, so now we've secured the build and we're providing assurance. We've helped kind of secure the architecture and the design phase of the architecture. So the last bit to go on is, let's look a little bit about security as we operate our systems. So we mentioned earlier on about kind of big vulnerabilities like Log4Shell. Now, I love this tweet. I think it's great. This is from the Register. Now, Log4Shell would have been a catastrophe without the Y2K-esque mobilization of engineers. Now, I'm sure a lot of you were affected by the Log4Shell vulnerability. I know my engagement certainly was. We were a Java shop. Now, everyone did a great job responding to that threat, and a lot of people put in a lot of hard work, a lot of hours to respond to it. But it was Y2K-esque. It was a huge undertaking, and there was a lot of disruption in terms of delivery and a lot of coordination activities. Sometimes for weeks, people are scrambling around, figuring out, are we safe yet? Have we found all the places we're using this thing yet? We can make this better. We can use the same techniques we've used before. So if we look at the kind of workflow that a lot of teams would have faced, Log4Shell drops, we need to find out where we're using this thing. It's critical, stop everything. So we scramble around, doing a code search, and we kind of look around, can we find a reliable way to understand where we're using this dependency, which is not as easy as it sounds. Search it through Git, we maybe write a Git scanner, that takes a couple of hours. Not sure if it's reliable or not. We pump those things into a spreadsheet. How do we know who owns what? It's very difficult to figure out from a repo who owns it. Is it even in production? No idea. We then send out wide comms as a catch-all and say, everybody, we think we know who's using Log4Shell, but we're not fully sure. Could you please just check anyway, just because it's that important? And then these app engineers over here in the red, every single team is checking, every single team is making sure that they're not vulnerable. A lot of duplicated effort there, a lot of coordination efforts. Whoever's in green here has had a pretty bad week or two, and it's something we can improve. Now, wouldn't it be amazing if we could just have something like this? What if you had a database where we could just, run a query? Say, right, tell me all the artifacts, all the repositories, which team owns them, when they were deployed to production that are using this dependency and this version, and get me all the latest ones that have been deployed. Now imagine having this power in that situation when it's kind of stop the presses and we're scrambling around trying to understand what do we do. So to achieve this kind of power, what we're going to do is now bring in threat response into how we operate our software. It's not just the responsibility of the InfoSec team now to try and figure out whether we're vulnerable or not as the system is operated, and try and help us figure out how we understand what's vulnerable. We're going to do that ourselves now. We're going to take on the ownership of some of that. So an approach I found to achieve that kind of query that we saw earlier on is basically building a bill of materials. So now a lot of places you could scan for this. You could try and scan the source code. We've already talked about why that's difficult. You could have a dependency scanner in your pipelines. These pipelines don't always run. You're going to miss a lot of artifacts there because somebody hasn't worked on the code in 6 months, and they're probably the most dangerous code bases that you have. A traditional approach would be to scan like an artifact store with a tool like Nexus or something like that. What we found though is a lot of those tools, they're very specialized for having a big pot of components and finding out if any of those components are vulnerable. They're not so good if you want to find out, well, who's using it and is it in production? Can I have a list of who's using it? Which is certainly what you need in this kind of log4shell scenario. So what we do is we built quite a lightweight script, which runs as a job. And all it does is it has two data sources. It pulls our production cluster. So we're using Kubernetes. It doesn't matter, whatever you're using in production, it can get information from that environment. And all it says is, what's in production, which artifacts are in production, and which are active right now. Then it looks at your artifact store, it pulls down the artifacts that were deployed. We run a tool called Sift, which is a very clever bill of materials tool. You give it any kind of archive, and it will go in there very greedily and understands lots of different file types and archive formats, pull out a list of all of the artifacts that are in there, nested, whatever, which versions are in there, and kick it all out as a JSON file. Again, we use a database that we create ourselves, very easy to put together. I think we had one engineer built this in less than 2 weeks by himself. And now we have a database where we have a query like this. If log4shell happens again, or any situation where we need to understand where we're using our third-party vulnerabilities, we write a query like this. Now, we actually went a step further and added a Grafana dashboard, so it's even easier. But imagine we had this capability during log4shell, we would have shortened a lot. We would have massively shortened the information gathering phase. We would have hugely shortened the coordination phase. And then verifying who'd fixed it and who hadn't, again, would have been much, much easier. And the tangible benefits there is, we're reducing the disruption that we experience as teams when one of these things happens. And it will happen again. Log4shell, I don't think it's going to be an isolated incident. It's easy to coordinate. We build this with effective systems, and it's easy to report to give the security teams, yeah, we definitely fixed it. This is how we know that we fixed it. It's not a spreadsheet that we've had to manually kind of tick off. We know we fixed it because that's what's in production, and we definitely scanned that thing. And we can also provide, evidence of the value we've added. We've got measured capability now for how long it took us to remediate, on average, these findings. And we can also measure what percentage of our teams do we actually have to disrupt to try and find out whether they were vulnerable to this to this threat. Especially in a large organization where you've got, tens, 50, hundreds of teams, that can be a huge time saving to say that only 35% of our teams had to disrupt their workflows, not 100%. So you would save a lot of time and effort with this kind of approach. Again, owning our own ability to operate our services securely. So that was the last kind of concrete technique that I wanted to go through. I'll just leave you with a couple of key takeaways. So the first one is you build it, you secure it. Again, you take control of securing your own software and demonstrating that software. And you have the power to do that in a way that works for you. It works on the languages that you want to use. It respects your workflows. It allows you to work iteratively and quickly. We need to have empathy and understand why it is that we need security assurance and understand the kind of tough job that these kind of InfoSec app specialists are in. They've got a tough gig trying to provide all this assurance for all these different teams that they represent. And finally, we just need to escape from kind of just pass the test. We don't just want to have security as a thing we do once and that's cool, it's secure now. We want to secure the system throughout the whole of its lifetime. And crucially, we want to prove the value of doing so with metrics and showing all the good work that we've achieved. So that is the end of the talk. Thank you very much for listening. And I'll hand it back over to you, Lisa. And I think any questions, fire them over.
All right. Thank you. Thank you. Let's stop our screen sharing so we can see more of your face. We have a kind of an observation in from Frank that they are trying to shift security left by performing early threat modeling as part of the design phase, long before anything is actually built. Is that something that maybe you've seen before or have dabbled in?
Yeah, so I knew somebody would talk about threat modeling. So I think threat modeling is an incredibly useful technique, and you get a very kind of deep understanding of the threats that your system's exposed to, and it's a very useful exercise. The problems I've seen with threat modeling is number one, the resources that it takes to carry out. So I think it's a fantastic tool, by the way, and you should do it. It's just, if we're trying to build something that's a process that allows us to release lots of different changes, more quickly and more securely, threat modeling takes a very long time to carry out, to do it properly. You're talking about maybe 3 or 4 hours per threat model with a group of 4 or 5 people potentially in the room. It's also quite a specialized skill set. So being able to do like a threat model that's kind of worth its salt takes a very technical security specialist to be able to do one. There is another option to train up your engineers in threat modeling techniques. And Martin Fowler did a great blog on how engineers can use threat modeling to carry out those, to do it themselves. I found it's difficult sometimes to turn the results of a threat model into the kind of assurance that you need for an InfoSec team to provide that assurance. You can see you've done a threat model. It can be difficult to categorize the things that you get out of it sometimes. You can use CWE. You can try and, again, put them into a database potentially, or find a format that allows you to structure that data so you can report on who's done a threat model and who hasn't. But they're all sort of challenges that mean, in the past, I've always had threat modeling as kind of a value-added thing that you do. It's something that's very useful and should be done, but it's something I find that's been difficult to build in as kind of a BAU process.
Great, thank you for that. And then we have, which course that you may know of has some good knowledge and training, perhaps for the DevSec-Oops role?
Yeah, I mean, so I think as I brushed past on my slides that, I started my career as an engineer and then became a security champion and then a lead security champion and then moved into security full time. So I think if you can create that security virtual team and engineers are dealing with these findings, that's by far the best way for them to learn. If they're working on a project to design our sequence management, a sequence management pattern or solution, that's the way they learn really the core aspects of sequence management. And that's the best way I've found to learn. Now, obviously, we do need some kind of like introductory training. There's a course I've always been fond of called Hacksplaining, and it's basically a free course. I think you get 70% of the course instructions for free. They're very short, like 5 to 10 minutes, very technical kind of courses on different like OWASP top 10 type attacks. And if you want to take the extra step and use that to prove that your champions are security trained, say you work in a regulated environment and you need to not just say I've got security champions, you need to prove that they've got a higher level of knowledge. You could pay a little bit extra. I think it's really cheap, maybe $20 a user or something. And they give you like a way to audit who's done what and produce a report on who's been trained. So I'd always say start with Hacksplaining. It's easy, it's cheap, it's free if you use, like the subset of trainings. And most engineers seem to enjoy it.
Awesome. And this is a good one. Any advice, always comes down to dollar and cents. Any advice on how to get funding to kick off a virtual AppSec team?
So I think, I think when we're talking about, we usually have to find either a business need to create these initiatives. or a security need to create these initiatives. So if it's a business need, we can latch on to a business critical project, or we can kind of latch on to the fact that a critical project was delayed and was over time because of security kind of assessment taking a long time. If it's from the other side, if it's from the security and risk team are saying they're going, you need more security, or they're trying to put like prohibitive controls in place that are affecting projects. Again, we can latch onto that and say, this is causing us a real impact. The way we can improve it is by having the budget for this virtual security team. If neither of those things work, sometimes it can be a case of just starting small, just try and get sign off for one engineer, or, even just like a few days of that engineer's time every now and again. Build something that's really cool, build something that has obvious benefits, like putting the scanning in and the insurance reports, get the blessing of the InfoSec team, and then demonstrate that in a really, super slick demo. And that might, again, help you to sort of get people switched on. If you don't have any of those kind of drivers and you don't have the ability to evangelize internally, it is going to be tough. They're the techniques I've used in the past. And if you don't have those things, it might be tough to get funding.
Great. So here is one. Why do you have to build, and you might have touched on this, why do you have to build the security pipeline scanner databases when we have tools like Nexus IQ?
Yeah, so those tools are, are fantastic for what they do, but I've often found, I think I touched on it with Nexus. So with Nexus, when I've used it in the past, it's very good at, if you have a big inventory of artifacts, it's very good at, and you want to proxy all the dependencies you pulled down from the internet through Nexus, and it'll tell you if they've got vulnerabilities at that time. It's very well suited for that. It's a big pot of artifacts, and those artifacts are constantly scanned. If you want to then draw a link back to which teams are using those artifacts and which teams are using those artifacts in production, often that can be quite difficult and challenging. There might be a lack of metadata in the tool. That could have changed, but certainly the last time we were using it, it was difficult to draw that line between who's using the artifacts and is it in production. And the APIs that we had available to us weren't allowing us to build this kind of capability that we needed. So I'm not saying don't use tools like Nexus. They have a very definite use case. But what I am saying is if you have a different use case where you want to use a new technology, or you just want to have engineer ownership of these tools, and you don't want to go through a lengthy procurement battle, and you don't want to pay a large amount of money for the tools, and you'd rather get kind of 6 for the price of 1, that's when you can use the kind of bring your own scanner approach. I don't think you'll get many engineering teams who will kind of want to go and procure Nexus and administer it and operate it. I think you might get a lot more engineering teams who want to sit there and go, yeah, let's use SemGrep. It took me 10 minutes to run a scan and build it into my pipelines.
That makes sense. And the organization has one of those more traditional InfoSec teams that's just acting as a kind of that last bastion before you go live, gatekeeper. What's your advice on introducing a similar sounding team in parentheses and more the virtual AppSec team?
I'm sorry, I didn't catch the last part of the question.
What advice can you give on introducing a similar sounding team, like the virtual AppSec team or the AppSec team?
Also, do you mean kind of having engineers sort of like fulfill that role and create like a security engineering team?
Yeah, and it seems like to be part of maybe that pre-go live determination.
Yeah, but I think the key thing again is this idea of value statement. If you can, it's not just an engineer saying, I feel a bit cagey about our security. I know there's a lot of holes there. I'm really worried about it. So I think we need more resources to fix these things. If whatever risk assessment you're doing isn't intensive enough and isn't pulling these things out, sometimes you have to kind of say, okay, well, let's do an assessment. Let's do a security assessment on these parts of the architecture, for example, or let's do an open SAM assessment on our security workflows. Build up a kind of industry standards. You can do that yourself. You can get these things online, do your self-assessment, build up the fact that the industry standard is here and your team is not. whether it's in terms of workflows or whether it's in terms of the security controls that you have. And then you can use that as a really powerful tool, kind of bargaining tool. You know, if you don't have the things I mentioned earlier, like a critical business project that's been delayed, or a kind of bulldog security team is telling you your stuff isn't secure, you can self-assess your own things, use these reports. No product owner wants to sit there and think, oh, well, actually, I'm not as secure as I should be, and my competitors. And you kind of, you know, you make somebody own it. You say, I've done this report. I think we need more resources to fix this stuff. Somebody's got to have this hot potato now. And some, you know, sometimes that can be a very effective way to suddenly find budget or impetus for these initiatives. You make it somebody's problem, basically, rather than just kind of, oh, I'm not sure about this. This is a bit funny. This is a bit weird.
What's the best approach to influence a security-first culture in a non-ICT small company?
Oh, wow. I'm gonna say it's probably not something I've had too much experience in. Yeah, I mean, I suppose, you know, the things that we looked at in this talk were kind of empathy and understanding why, you know, why we should care about security assurance. It's not just theatre, it's not just a box tick. We need to understand that these people are doing a difficult job for a reason, and it's part of our role to help them do that. So yeah, I guess maybe use the same techniques. I know we've all done the kind of corporate security training where it explains why you've got to keep your desks clear. You know, you watch a video where somebody sneaks into the office and steals a USB stick with, you know, with all the accounts on it, and there's a data breach. I guess just paint the picture, yeah. It can be helpful to get, you know, to get somebody in who's a trainer who can kind of bring it to life. I remember when I was an engineer, we had a penetration tester come in who blew our minds by showing us how to hack systems in real time. And that really turned me on to, okay, you know, I want to pursue a career in security. I don't know whether there's the equivalent for a small business where you can get somebody to come in for an hour or two and blow everyone's socks off with a cool security presentation. But yeah, that's just from the top of my head. I don't have experience in that, but good luck with it.
That's really interesting. Get a hacker to come in and convert them to security. I like it.
They're the best talks. If you ever go to a conference and there's a security talk, it's always packed to the rafters when somebody who is a red teamer explains how they hack systems, how they broke into that office, you know, how they tailgated somebody and put a USB stick in. Everyone loves it. So yeah, maybe find somebody who can do that for you. Or
find your inner hacker in you.
Yeah.
All right, I think this might be our last question from Paul. Did you look at the OWASP dependencies track rather than build your own database and dashboards?
Yeah, that's a good question. So the dependency tracker or the dependency scanner?
I think it's a dependency track.
So no, we didn't look at that. We already had the bill of materials capability anyway, because of a project that we carried out to try and upgrade some database drivers, which were going to basically break systems if we didn't upgrade them in time. So we already had this ability for the bill of materials. What we then did in response to Log4j was that we already have this kind of there. Let's build a process around it so that we can use it in a security context, test that it works the way that we should do, and we get the right information. We tweaked it a bit, and then we used it for that use case. I wasn't aware that OWASP had brought out dependency track, and if I'm going to look at it as soon as this talk's finished. If it's good and it does that job and it's lightweight and engineers can own it, fantastic. You know, use that as well. We used something that our engineers had, you know, a lot of familiarity with. It was tech that we knew and understood. We could build it and manage and operate it very quickly. So yeah, it's probably one of those cases where if everything's if you've got a hammer, everything looks like a nail. But we got something really good in less than 2 weeks, so it worked for us. I will check it out though. Thank you for mentioning that tool.
I love it. All right, well, Chris, thank you so much. And many thanks to everyone for your questions and everyone else in the audience. I hope you've all found it a really useful session, and we'll send out the recorded version shortly. And our next talk is going to be on Tuesday. We're shaking it up. Usually we're Wednesdays, September 27th at 8:30 a.m. BST time, how to get machine learning right and make data work harder. We're going to learn from Shri at Travelopia and Simon Case here from our data practice of Equal Experts. You can find us at equalexperts.com/equalexpertstalk. And if you're interested in learning more, you can go to our website and you can join EE community and find out all the different places that we're speaking besides the expert type talks online. So thank you all. And I think that is a wrap for today.